Welcome to Husay Sipnayan. In this video presentation, let us discuss using Gauss Elimination Method in solving system of linear equations in three variables. Please subscribe and click that notification bell to be updated with our math video lessons. Before we continue, let us have a recall of some important concepts. Coefficient matrix. This is a matrix consisting of the coefficients of the variables in a system of linear equations. Augmented matrix, on the other hand, is a matrix in which each row represents the coefficients of the variables and the constant term in an equation, and each column represents all the coefficients for a single variable. Let us have an example. In the system of equations in three variables, x minus 2y plus 3z equals 7, 2x minus y plus z equals 4, and negative 3x plus 2y minus 2z equals negative 10. The coefficient matrix is the matrix with elements 1, negative 2, 3 on the first row, 2, negative 1, 1 on the second row, and negative 3, 2, negative 2 on the third row. Notice that the equations in the system are written in the standard form, so that in the coefficient matrix, the first column are the coefficients of the x variables in the three equations. The second column are the coefficients of the y variable in the three equations, and in the third column, we have the coefficients of the z variable. The augmented matrix for this system of equation is 1, negative 2, 3, 7. This now includes the constant term in the equation. Second row, we have 2, negative 1, 1, 4. And in the third row, we have negative 3, 2, negative 2, negative 10. In the augmented matrix, we have an additional column consisting of the constant terms in the three equations. Next, let us have upper triangular matrix. This is a matrix wherein all the elements below the main diagonal are zeros. On the other hand, the lower triangular matrix is a matrix wherein all the elements above the main diagonal are zeros. Let us have an example. 1, negative 2, 3, 0, negative 1, 1, 0, 0, negative 2 is an example of an upper triangular matrix. Notice that the elements below the main diagonal are zeros. The matrix with elements 1, 0, 0, 2, negative 1, 0, and negative 3, 2, negative 2 is an example of a lower triangular matrix. Notice that the elements above the main diagonal of this matrix are zeros. This time, let us proceed to Gauss elimination. This is a method also known as the row reduction algorithm for solving system of linear equations. It consists of a sequence of operations performed on the corresponding matrix of coefficients. The operations in the Gauss elimination are called elementary operations. Elementary operations for rows are the following: interchange of two rows, multiplication of a row by a non-zero constant, and addition of a constant multiple of one row to another row. Two matrices are said to be row equivalent if one matrix can be obtained from the other by using elementary row operations. The row echelon form. A matrix is in row echelon form if the lower left quadrant of the matrix has all zero entries. In each row that is not all zeros, the first entry is a 1. The diagonal elements of the coefficient matrix are all 1. Let us have an example. The matrix 1, negative 2, 2.5, 18, 0, 1, negative 14.5, negative 61, 0, 0, 1, 4 is an example of a matrix in row echelon form. This time, let us proceed to Gauss elimination for solving a system of equations. The following procedures may be followed in solving a system of linear equations in 3 variables or more using the Gauss elimination method. First, write the augmented matrix of the system. Next, use elementary row operations to construct a row equivalent matrix in row echelon form. Third, write the system of equations corresponding to the matrix in row echelon form. Then use back substitution to find the solution to the system. Let us have some examples. Example number 1. Solve the system 3x plus 2y minus z equals negative 1. Second equation, negative 2x minus 2y plus 3z equals 5. Third equation, 5x plus 2y minus z equals 3. This is our suggested solution. First, let us write the augmented matrix for the system, and it is given by 3, negative 2, 5 on the first column. These are the coefficients of x. 2, negative 2, 2. These are the coefficients of y in the system. Negative 1, 3, negative 1 in the third column. These are the coefficients of z. Then we have the last column for the constant terms in the equations. We have negative 1, 5, 3. Remember to write all the equations in the system in standard form before writing the augmented matrix. For Gauss elimination, the augmented matrix is used so that both the coefficient matrix and the constant matrix can be manipulated together. From the augmented matrix form, let us have R sub 1 for row 1, R sub 2 for row 2, and R sub 3 for row 3. This time we're going to perform elementary operations on these rows so that we will have an upper triangular matrix in the coefficient matrix of this augmented matrix form. To do that, let us have 2r sub 1 plus 3r sub 2 for the second row of the original matrix. So that we will have 2 times 3 plus 3 times negative 2. That will be 0 on the second row first column element. We'll do the same with the other elements for the second row, and we will retain r sub 1 and r sub 3. So that we will have a new matrix. Second row, first element is 0. Then we have negative 2. That is from 2 times 2, 4. Plus 3 times negative 2, negative 6. So we have 4 plus negative 6, that is negative 2. Next element, we have 7. That is from 2 times negative 1 plus 3 times 3. So we have negative 2 plus 9. We have 7. And the second row on the constant matrix, we have 2 times negative 1, that is negative 2. Plus 3 times 5, that is 15. So we have negative 2 plus 15. We have 13. Next, we need to have the third row first column element to be 0. And to do that, we will have the operation 5r sub 1 minus 3r sub 3. So that the third row first column element will be 5 times 3, that is 15, minus 3 times 5, that is also 15. So we have 15 minus 15, 0. And then we will have r sub 1 and r sub 2 retained in the next matrix. Then we will have the elements 0. For the second column element in the third row, we have 4, that is 5 times 2, 10, minus 3 times 2, that is 6. So we have 10 minus 6 equal to 4. The next element is negative 2. We have 5 times negative 1, that is negative 5. Negative 3 times negative 1, that is positive 3. So we have negative 5 plus 3, negative 2. And then negative 14, we have 5 times negative 1, that is negative 5. And then negative 3 times 3, that will be negative 9. Negative 5 minus 9, negative 14. Next, we should have the third row second column element to be 0. And to do that, we will have the operation 2r sub 2 plus r sub 3. And then we will retain r sub 1 and r sub 2. So that we have 0 is 2 times 0 plus 0. Next, we have 2 times negative 2 plus 4, 0. And then we have 2 times 7, 14, plus negative 2, we have 12. And then next, we have 2 times 13, 26, plus negative 14, we have 12. This time, we already have an upper triangular matrix in the coefficients matrix. We can write this in its row echelon form by multiplying all terms or all elements in the third row by 1 over 12. Also multiplying all elements in the second row by negative 1 over 2. And multiplying all terms in the first row by 1 over 3. However, we're not going to do that anymore because we can already solve the system of linear equation if we're going to rewrite the system based on this matrix. So we have 3x plus 2y minus z equals negative 1 in the first equation. Negative 2y plus 7z is equal to 13 for the second equation. And 12z equals 12 for the third equation. And since 12z is equal to 12, then we can divide both sides of this equation by 12 to get the value of z. Z is equal to 1. Now, substituting z equals 1 to the second equation, we can get the value of y. So we have negative 2 times y plus 7 times 1, that is the value of z, equals 13. Subtracting both sides of this equation by 7, and then dividing both sides of the resulting equation by negative 2, we will get the value of y as equal to negative 3. Now, substituting z is equal to 1 and y is equal to negative 3 to the first equation in the system, we will be able to get the value of x. So we have 3x minus 2 times negative 3 minus 1 is equal to negative 1. Solving for x in this equation, we will get x is equal to 2. Hence, the solution to the system of equation in 3 variables is the ordered triple 2, negatives 3, 1. Let us have example number 2. Solve the system 4x minus 2y plus 3z equals 11, x plus 4y plus 2z equals negative 12, and 3x plus y minus 5z equals 8. Here is our solution by Gauss elimination. First, we're going to write the augmented matrix for the system. So we have 4, negative 2, 3, 11 in the first row, 1, 4, 2, negative 12 in the second row, 3, 1, negative 5, 8 in the third row. Remember to write all the equations in standard form before forming the augmented matrix. From this matrix, let us name R sub 1 as row 1, R sub 2 as row 2, and R sub 3 as row 3. So we are ready to perform row operations to have the second row first column element to be 0. To do that, we're going to have R sub 1 minus 4 R sub 2. And then we're going to retain the elements in row 1 and row 3. So we have, for the second row, first column element, that will be 4 minus 4 times 1, that is equal to 0. Next element, we have negative 2 minus 4 times 4. So we have negative 2 minus 16, negative 18. Next element, we have 3 minus 4 times 2. So we have 3 minus 8, that is negative 5. For the second row element in the constant matrix, we have 11 minus 4 times negative 12, that is 48. So we have 11 minus negative 48, 59. This time, we will have the third row first column element to be 0, and to do that, we'll have the operation 3r sub 1 minus 4r sub 3. And then we're going to retain the elements in row 1 and row 2. Let us perform the operation. So we have 3 times 4 minus 4 times 3. That will be 12 minus 12, 0. Next element, we have 3 times negative 2, that is negative 6, minus 4 times 1, that is 4. Negative 6 minus 4 is negative 10. Next, we have 3 times 3 minus 4 times negative 5. So we have 9 plus 20, positive 29. And then for the third row element in the constant matrix, we have 3 times 11, 33, minus 4 times 8, that is 32. So 33 minus 32, that is equal to 1. Next, the third row second column element must be 0 to have an upper triangular matrix. And to do that, we'll do the operation 5r sub 2 minus 9r sub 3. And then we're going to retain the elements in row 1 and row 2 from the previous matrix. Let us have the elements in the third row. So we have 0, that is 5 times 0 minus 9 times 0, and then we have 0. Next, 5 times negative 18, that is negative 90, minus 9 times negative 10, negative 90. So we have negative 90 minus negative 90, that will be 0. For the third column element in the third row, we have 5 times negative 5, that is negative 25, minus 9 times 29, we have negative 286. Third row element in the constant matrix, we have 5 times 59 minus 9 times 1, we have 286. Again, we will not write this matrix in the row echelon form. We will just rewrite the system of equation so that we have 4x minus 2y plus 3z equals 11 in the first equation. Negative 18y minus 5z equals 59 in the second equation. And negative 286z equals 286 in the third equation. So from the third equation, dividing both sides by negative 286, we have z is equal to negative 1. Substituting z equals negative 1 to the second equation, we have negative 18y minus 5 times negative 1 equals 59. Solving for y, we get y equals negative 3. And then, substituting z equals negative 1 and y equals negative 3 to the first equation, we'll have 4x minus 2 times negative 3 plus 3 times negative 1 equals 11. Solving for x in this equation, we will get x is equal to 2. So the solution to this system of equations in 3 variables is the ordered triple 2, negative 3, negative 1. For example number 3, let us have a word problem. There are 3 boys, Andy, Benny, and Cardi. The sum of their ages is 20 years. Andy's age added to Cardi's age is 4 times Benny's age. And Benny's age added to Andy's age is 4 times Cardi's age. How old are the 3 boys? Here's our solution. For our representation, let A be Andy's age, B be Benny's age, and C be Cardi's age. Hence, we can form the 3 equations from the statements in the problem. Since the sum of their ages is 20, then we have A plus B plus C equals 20. For the next equation, we have Andy's age added to Cardi's age is 4 times Benny's age. So we have A plus C equals 4B. For the last equation, we have Benny's age added to Andy's age is 4 times Cardi's age. So we have B plus A equals 4C. This time we already have the system of equations in 3 variables, A, B, and C. First, let us rewrite the 3 equations in standard form so that we have A plus B plus C equals 20 for the first equation. A minus 4B plus C equals 0 for the second equation. And A plus B minus 4C equals 0 for the third equation. From these equations in 3 variables written in standard form, we can write the augmented matrix 1, 1, 1, 20, 1, negative 4, 1, 0, and 1, 1, negative 4, 0. Let us label the rows as R sub 1, R sub 2, and R sub 3 for row 1, 2, and 3 respectively. We're going to form the upper triangular matrix in the coefficients matrix. So we will have the operation R sub 1 minus R sub 2 so that the second row first column element will be 0. Simultaneously, let us write the third row first column element to be 0, and we will have the operation R sub 1 minus R sub 3. And then let us retain the elements in row 1. Let us proceed to the elements in the second row so that we will have 1 minus 1, 0. 1 minus negative 4, that is 5. 1 minus 1, that is 0. And then 20 minus 0, that is 20. For the elements in the third row, we have 1 minus 1, 0. Also 1 minus 1, 0. 1 minus negative 4, that is 5. And 20 minus 0, that is 20. That easy, we already have an upper triangular matrix in the coefficients matrix. So we can now write the system of equations from this matrix. We have A plus B plus C equals 20. And then we have, since the elements in the second column are the coefficients of the B variable, so we have 5B equals 20. Also, the elements in the third column of the coefficients matrix, these are the coefficients of C. Then, for the third equation, we have 5C equals 20. Solving for A, B, and C, since 5C is equal to 20, dividing both sides by 5, we have C is equal to 4. Also, from the second equation, we have 5B equals 20, dividing both sides by 5, B is equal to 4. And substituting B equals 4 and C equals 4 to the first equation, we have A plus 4 equals 20. And from here, A is equal to 12. Hence, Andy is 12 years old since A equals 12. Benny is 4 years old since B is equal to 4. And Cardi is 4 years old since C is equal to 4. That will be all. Thank you for watching. Please subscribe for more math lessons.